Today, we're visiting a relic of a stellar explosion humans saw in the sky nearly 1,000 years ago. The Crab Nebula, Messier 1, in Taurus. What is it exactly? A supernova remnant recorded in AD 1054. For about 3 weeks, that guest star was visible in daylight and at night for almost 2 years. What remains is a cloud still expanding, filament by filament, as if we were watching a very slow movie. It sits about 6,500 light-years away. At the center is a pulsar, the collapsed core of the star, now a city-sized neutron star. It spins in 0.033 seconds, 33 milliseconds, and sends out pulses in radio, visible light, X-rays, and gamma rays. Imagine a lighthouse blinking 30 times per second. How do we know all this? From light across the spectrum. In optical light with Hubble, colors mark elements. Red for hydrogen and nitrogen, green-blue for oxygen, sketching the filaments of the blast. In X-rays with Chandra, we see the engine inside, the Pulsar wind nebula, a torus and polar jets, a swirling storm of synchrotron radiation that injects energy and sculpts the web from within. Synchrotron is non-thermal light from charged particles moving near light speed, forced into curved paths by magnetic fields. Compare images years apart, and you'll notice it growing. We can measure its expansion and wind the clock back to 1054. What can we learn from this color show? First, how massive stars die. A supernova isn't just an ending. It's a chemical furnace that spreads heavy elements, the stuff of planets, atmospheres, and life. Second, how a natural particle accelerator works. The pulsar turns rotational energy into ultra-fast particles, shaping rings, jets, and shock waves through the nebula. Third, that the sky changes, slowly, but on human timescales. The crab is one of the few objects where change is visible over decades. Details I love. In high-resolution images, tangled filaments, rich in sulfur and oxygen, flicker as their ionization changes. The pulsar doesn't just beat, its period trembles with tiny glitches, clues to a superfluid interior. And the nebula's broad, nearly flat spectrum is the classic signature of synchrotron. Why does it matter today? Because the crab is a natural laboratory. It shows how elements are made and how particles are accelerated in our universe, and it links medieval observers to modern telescopes. Same story, new questions. A star exploded. We saw it in 1054. What remains is a cloud that grows and a pulsar that beats 33 times per second. From the end of a star, new beginnings are born.